Hey everyone, it's Matt here from the MattExzy. Bloody hell, I'm going to leave that in. It's Matt here from the MattExzy YouTube channel, and I'm going to show you how you too can put together a numbers station. Well, not really, because you need a one-time pad, and I'm not quite that smart yet. But I'm going to show you how I've modified code from the K6HX. That's the fellow who first designed that Morse code beacon code back in 2009, I think it was, and I featured it in a previous video showing you how to key on a QRP kit with a little bit of code. I've modified that somewhat so that we can use a time chip. Let me manually focus this camera. Bloody hell, this is a DS3231 real-time clock chip. You might notice that there's a 2032 cell battery there that you might find on the BIOS battery of your motherboard in your computer. That just keeps the time in this chip. So that's one little piece of this. You'll also notice a LCD screen hooked up to this and a relay to turn on the QRP circuit. I tried using a MOSFET and a TIP 120 chip to turn it on, but because I need to use ground to key in the actual Morse code, see, this transistor is acting like a Morse code key, it created a ground loop, so the only way to turn this on to a schedule is with a relay. Yeah, stay tuned and we shall explore this conglomeration a little further. So first things first, for this demonstration I'm using the Rockmite kit that is also featured in a previous video, but I have removed its microcontroller. Reason being that when I started experimenting with using transistor keys, the microcontroller kind of just crapped out on me. And I've noticed that a lot of other people with this kit have taken it out. There's no real way to modify the code in the microcontroller, so I don't have the schematic with me, but if you can follow, they're the pins that are jumped, and I think I've jumped those pins with a 10k resistor. 10k or up should do. You know, I wouldn't use anything silly like a 1 million gazillion ohms, but that should do. But this setup will work with any QRP kit you have, so the Frogs kit, the Pixie kit, and if you modify a Rockmite kit, well, with Rockmite. So we'll jump straight into things. When this clock hits 6 o'clock, and the seconds are 5 seconds, the relay is going to click on, like that. And at 5 seconds, this will happen. MattExzy says hi. By and large, the LCD isn't really needed. I had to do some sort of ugly code things to get this to work. The code that I wrote actually won't even compile on the latest version of the Arduino IDE, so I don't want anyone to copy my code and copy my mistakes, but it will just give you an idea of what can generally be done. So the Arduino is currently running off USB power here, but you can also power it off, VIN, it makes no difference. So that's the 12 volt supply for the transmitter circuit, and that gets turned on by the relay, which is controlled by the Arduino. I'm switching on the relay using another S9013 transistor because I've noticed that some Arduinos can't power on a relay module individually by themselves. Man, I love blue LEDs. Blue LEDs are awesome. So that's how that's running the schedule. The hardware is kind of self-explanatory. The secrets are all in the code. So what we'll do is we'll just have a look at the code. So we're using several different libraries to make this all work. Obviously we need the liquid crystal library, we need the wire library, and we need the library for the real-time clock. I'm using the analog pins 4 and 5 on my Arduino to read the time. Some people use the actual SDA and SCL pins on the Arduino. I'm sure I could do that, but this is just the way that I found it to work. So this line of code here is initializing the lines on the LCD screen. This code is all originally by K6HX. That's all his code. I didn't make this Morse code reference here. So this is the speed that we're sending the Morse code, 18 words per minute. These are my pins. LED pin is actually being used to key on the Morse code keyer transistor, and this is how the QRP circuit that you're using will transmit on and off. I'm using pin 10 to turn on the relay for the power supply, and I'm using pin 6 as just to turn on a light to let me know that the schedule's been reached and it's turning on its pin. And hour, minute, seconds, that's all real-time clock stuff. I'll just scroll through this slowly so you can get an idea of what I'm doing. If C equals, this will be your message here. So we clear the LCD and we print C. C is the message. There we go, return the LCD clear for the next line. A little bit more code. Now when you're setting time on your real-time clock, you'll only have to do this once. So you can see I've set it here to Thursday at 5:59 in the PM. So you upload this once to your Arduino and then you comment the line. See, when I comment that line and it goes grey, then the next time you upload this, the time won't get reset. That had me really confused for about a week before I figured that out. So that's one essential part. So this isn't really a how-to, it's more of a what not, well, just things to avoid. Then we get down to the actual guts of the program itself. Down here. So this part here displays the time on the LCD screen. And here we get to my absolute terrible code writing. This would actually be better coded as what's called a switch case, but I haven't gotten around to figuring my head around that yet. So what this is the schedule to turn the circuit on if hour equals 18, so 6 PM, 2 AM or 4 AM. Power on will turn on the relay, power light turns on the power light, and if the time is any other time, low, so we turn the circuit off. Now this line here I should really have in what's called parentheses or brackets. Coding for Arduino is very new to me, so I myself am still wrapping my head around it. So this is what tells the Arduino when to actually tap out the code. So if it's this hour and the seconds equals such and such, well then it's going to send that message one time per minute. And we need to clear the LCD of the time, so that's why LCD clear is there. Then whatever is in these quotation marks in this send message void, that is your message that gets sent. And then we clear again, and I've just written a little message here, TX mode, to let me know that the message has been sent, and a delay of 2000 microseconds. The delay command in Arduino code is not really that great to use. Because I'm using a real-time clock, it's not such a big deal because the Arduino will always catch up with time anyway. Even if the Arduino loses power and you've uncommented the time that you've set here, it will always go back to that time that's set, as long as that little CR2032 battery is okay, just like an ordinary real-time clock. So if the hour is such and such and the second is such and such, it'll tap out that message. Else, send message, in quotation marks, nothing. No space or nothing. It won't send anything, and all it will do otherwise is display the time. So I'm not going to post this code on GitHub or anything because it's not that, I don't know if it's that legit, if it's that, you know, how we should write code, but I'll just scroll through this once again slowly. So if you would like to, first of all, you should go to the original K6HX Morse beacon code and just add in the little bits and pieces like I've done like this. So I'll scroll through slowly and you can just get an idea of the structure of the code itself. It's all very self-explanatory once you see it on your own screen. All we're really doing is just putting in the little bits and pieces like the LCD code, the code for the real-time clock, and that's it. And just setting these little conditions, you know, if such and such is such and such, we'll then do such and such. And that's the gist of what Arduino is. Some people don't like to use if statements, some people like to write case statements, but this is what works for now, and it's just a little demonstration. So, is that microseconds or is it milliseconds? That 2000 equals 2 seconds. We'll say that. So there's a few little concepts to try and grasp in this video, obviously. Obviously, you shouldn't be making your own number stations because well, governments are allowed to make their own number stations, but you probably shouldn't make your own number stations or do anything to interfere with the licensed bands on amateur radio. I myself am not a licensed amateur and I'm not giving anyone any advice on what to do. I limit myself and my little experiments through this little dummy load resistor here. I don't actually transmit. I just find the whole process very fascinating of putting together these kits and having it all come together and all work. But in reality, like if you are an amateur radio operator and you can make a beacon, the LCD screen isn't essential. It's a very nice to have and it shows you in real time in what message is being tapped out. And any other time it just shows you the date and time, which I think is a nice little feature to have. So, thanks for watching.